Okay, we're in section 29 of the notes, and we're looking over the SAGE code. This problem should look somewhat familiar to you. And what I mean by that, it's really the first thing we introduced to you. All right, I'm going to scroll back to the beginning of the notes. And explain this to you, that what we're doing over here. We're doing this problem right over here. Now, certainly I'm going to open up SAGE. And when I do that, I'm going to claim that I have a memory of the past, although it may not be great. All right. And I'm going to say, I think we've done, solving equation before. Let me reset. Let me say X is a var. Oops. And let me just see if I can solve. And you'll see what happens. Now, remember, in SAGE or any upper level math course you take, the natural log is just simply just log. So log of what? X plus 4 is equal to, that's a double equal sign. That means it's an equation. And we want to solve for X. And let's see what happens. Now, it returns back to me. It just simply says, oh, yeah, X equals log X plus 4. In other words, it didn't solve. So then I'm going to conjure up my memory. And I think we've done find root. I'm going to hit the tab button now and show you what happens. It just filled it in for me. So I just hit the tab. Now, if I just do find, look at all the stuff that comes up. And if I want to just simply say find root, you see that? Okay. That's nice about SAGE. Find root, and we want log X plus 4 is equal to X. And I want to tell it, approximately where I believe the root is. So let me scroll this through the notes, and I want to tell you there's a picture. Now, someone says, what's the picture of? This is the picture, and you should notice from Math 119, this curve over here is a picture of log X plus 4, and this is the picture of the line Y equals X. So I'm going to claim over here, I'm seeing a solution, and to me, looking at the picture over here, it looks like it's between 1 and 2. I also want to point out, for the students that have a hard time seeing things, you can blow stuff up. And this scales nicely. I'm just using my mouse to blow it up. So I'm going to say my solution between 1 and 2. So I'm going to say between 1 and 2. I'm hoping I remember that right. There you go. So what it said the solution is 1.74. You know what I want to do? I want to just scroll back over my notes, and I want to see if we have that answer down. I don't know. We use Newton's method to do it, right? A lot of work. Well, they didn't get that one. They got this one. So let's see if we can do it. I know it's tough. I'm going to look at this one over here. Let me go back to my, let me blow it up first. And clearly I'm seeing it's certainly, this curve here is asymptotic with the -4. So I'm going to say the solution is between -4 and -3. Let me go back to SAGE, and let's see how it does. Who knows? Maybe it's not going to be able to do it. Nope, I don't want to go to 3. That's too far of an interval, right? And let's see what it does. And it gives me an answer. Let's see if it's the same answer I got over here with my, my technique of using Newton's method. Give me a second. Yeah, that's a lot of work, right? Let's see what they got over there. And I'm looking at it, and minus 3.98, 133, 937, 09, 1132. Well, you know what? This gives a lot more precision here. I think you can see that. I can't say a lot more precision. All right, not a lot. All right, so that's not bad. We know a machine can do it. All right, but what are we trying to do? We're really not trying to solve an equation. We're trying to learn Newton's method. That's what we're trying to do. We're not trying to solve an equation. We're actually trying to learn Newton's method. So what I want to do is I want to go back. I'm going to clear this out now. I'm going to go back and demonstrate how to use SAGE to do Newton's method. Now again, someone's going to say, do I need to use SAGE? No, but you need to learn how to do Newton's method on a computer. It lends itself to a computer. So I'm going to go back to the SAGE business. I'm right over here. And I'll just type it in, although I don't type reset it again, I'll just do it. Remember, X is a variable in Sage, but I think it's a good idea just to write it down anyway. And I'll talk about this in detail. Now, this thing over here, remember when you were being introduced to using Newton's method, I said, whoops, I said write down the solve the equation. Remember, the equation was log x plus 4 equals x. You solve for 0, and that's what we recommend you do. All right, so log, and it's x plus 4, right, minus x. Okay. And then what I would do is, let's take a look at this. df, I think I'm doing this for a while, right? The df, I'm going to assign the derivative of that with respect to x. I'm going to plot f of x between -6 and 3. Again, if this doesn't, whoops, I made a mistake already. If this doesn't work out, we'll take a look at the picture. And if the picture doesn't look good, I'll have to revise it and try again. Okay, looks like I did all right. All right, it looks like I did all right. So, I want to go back to my notes though. And I want to see, I'm noticing though something weird about this over here. Do you notice that? It kind of stopped there. I was kind of expecting it to go on and be asymptotic with the -4. I was expecting it. Now, somebody says, oh, it's the artifact, I just wouldn't want to do it. But do you notice when I hit the return button, you sort of like error message? Let me go back over that, see if it's still there. And I want to tell you something about this over here. It says warning when plotting. It failed to evaluate function at 45 points. So you got to start to realize that what Sage is doing is evaluating this function at a large number of points, and it couldn't do it for some reason, right? It's actually telling that to me, which is nice. So what I want to do is I want to try different software. Don't be alarmed. This is going to happen to you a lot with software. Go back and try different software. I'm going to do that now. I want to try different software. And I think we've been talking about this for a while. I'm going to go back to Grapher, right? So I'm going to go back to Grapher. And when I use Grapher, what I'm going to be doing is I'm going to be graphing the same exact function that we just did. All right, the same exact function. So let me graph it up. And what am I going to graph up there? I'm going to graph the natural log. Now, Grapher, since Grapher is really, it's geared towards, I think, a more primitive audience than Sage or Mathematica. I type in ln, which is what you guys are used to seeing, which is the natural log. Remember, Sage, log is natural log, all right, minus x. Let's see how this one does. I like this graph better. I really do. This is commercial software. I'm seeing the asymptotic behavior over here with the line, x equals -4. But what I'm claiming over here is that Sage didn't do a bad job. It seemed to have a hard time evaluating points in this region over here. Let me go back to the graph for you. And I want to point out, it seemed to have a hard time evaluating points over here. I'm not sure why. You'd have to look at the code to figure that out. I'm not willing to do it though. I'm just going to say, hey, listen, it couldn't do what I wanted it to do. So I want to do a different application. I use Grapher. Now, if you had no knowledge of these functions, like if you didn't study Math 119, none of this would make sense to you, or even why you'd get a different tool out. That's why it's so important you have a foundation. All right. So let me go back, and I think I plotted it okay. And what I want to do is I want to look at the Sage code, and I'm going to clear the screen again. Let me repeat this. Clear does not get rid of my work. It just gets rid of the nonsense on the screen. And I'm going to say x0 or x0 is going to be assigned the value minus 3.98. Okay. Now, what do I have to do to get, the next guess? Well, let's talk about Newton's method then. All right. What's Newton's method? I'm going to define a new function, g of x, and g of x is going to be equal to, I'm going to say my first guess, whatever that could be. I'll just simply say it's x. Who knows what that's going to be? Minus f of x divide by the derivative. And we've already computed that. I hope you remember that. We called that df. All right. And again, if I make a mistake, it's going to tell me I made a mistake. Wow, no mistake. So what am I going to do now? Well, I'm going to start making guesses, but I've already made a guess. I want a new guess. My new guess, I'm going to call x1. And what's x1 going to be? It's going to be a sine g of x naught. I'm going to change my code a little tiny bit. Semicolon, and I want to display x1. All right, let's see if I do. Let's see if I can remember correctly. Okay. I want to go back over here, and I want to show you we did this, or at least we asked you to do it. I said I did it. We wanted you to do it, and we're doing it now. So let's take a look. Scrolling back in the notes. And remember, I said my first guess was this, and now the x1 would produce this number over here. Well, I see it. Now I want to do x2, right? So x2 will be g of x1, right? And what am I going to do? I want to display x2 now. And let's see if we got it. Minus 3.98 looks pretty good. We got it. Let's see if we can get x3. What's x3 going to be? G evaluated at x2. And I want to display x3 now. And what's x3 is this number over here. Now it looks pretty good. Now again, when I say it looks good, it's the same number. Am I doing digit by digit? No, but it's the same number. All right, let's do x4. What's that going to be? G of x3. And I want to display x4 now. All right, I'm looking at that. I'm looking at x4. It looks pretty good. Let's do x5. That's going to be G. And I could do this all day long, by the way. There's a point to it, though. We don't want to do anything all day long. Now, what do I notice there? X5 and X4 are identical. Oh, there's no change. That's what we said in the notes. No change. We said no change. Right now, we've got code here that hopefully you're going to learn on and be able to reuse. So let me go back. I want to scroll through the notes. And this one says redo the example. Right now, what example do I want to redo? That example. Well, I want to do it. I want to do it again. Now, someone says they have the code base. Why not just take the code you've already used? And I'm going to do that. All right, so what I'm going to do, x naught equals 1.75. Whoops. They're telling me to use that, by the way. X1 would equal G of X naught or X0. I would like to display X1. And let's see if we got it. Yep. Let's do X2. What's that? It's G of X1. And I would like to display X2. right, let's take a look. Pretty good. Let's do x3. What's x3? G of x2. And I would like to display x. Get this number over here. I hope you can agree, looking at x2 and looking at x3, they're identical. There is no change. I mean, if you keep doing this over and over again, there'll be no change over and over again. All right, no change. Okay, let me just go back to the Sage code briefly, make sure we covered it out. And you're seeing how to use Sage, right? You're seeing how to use Sage for Newton's method. But remember, Sage also has that find root operation. Now, granted, I have not looked at the code for that. I'm not saying how they've done that. I don't know. I'm sure they use some spiffy numerical analysis to figure these problems out. But the bottom line is, you know some numerical analysis. And what's that? You know Newton's method now. It's a numerical technique. All right. So over here, I did something similar. The only difference is I'm displaying the variables right after I do it. All right. Right after I do it. Okay. Thank you.